Hello, my name is Samia and I'm the Professional Market Product Manager for Maple. My role is to talk to our users and customers and to help them better understand our tools, technologies and services. This is a quick start training video for Maple. Let's start by looking at a couple of complete applications from the application gallery in the engineering portal. Maple is a broad, flexible tool, and a Maple application can have many different looks, and this is just one particular look for a Maple worksheet. Here I have drop-down menus and text boxes which allow me to change parameter values. Updated results are given here. As well as these simple UI elements, I could also have dials, gauges, radio buttons, checkboxes, and a variety of other graphical widgets in my worksheet. I'm not looking at any math, I'm not exposing any detail, I just have input parameters and results. This type of application we could actually deploy free of charge in the Maple Player. The Maple Player is a free runtime version of Maple. The concept is that you use your main license of Maple to create applications like this. You add interactivity with your UI elements, and then you deploy it free of charge using the Maple Player. The Maple Player is actually a free download from the MapleSoft website. You can also have Maple worksheets that look like this. Here I have a title, a description, and a diagram of the problem domain. I then have some equations which I've entered in proper mathematical notation. I then have some parameter values. I then analyze my equations and get some results. A Maple document is fully electronic, so if I change some parameter values here and I hit this button, those changes cascade throughout the length of my Maple worksheet and all of my results update. When you first load up Maple, this is what you're presented with. A white worksheet-based interface together with palettes on the left-hand side, menu items at the top, and Maple has a tabbed interface so you can rapidly switch between different applications. At its simplest level, you can use Maple as a glorified calculator. So type in 1 plus 2 divided by 2.3, hit Control equals, and Maple gives you the result. If you right click on this, you can format the result to a specific number of decimal places. You can also define variables in your Maple worksheet and do calculations with those variables. And again, if I change the values of x and y and I hit this button, Maple gives me updated results here. If I change the value of y here to an analytical value that I've derived elsewhere, if I hit this button, Maple maintains my analytical dependencies. Maple has lots you can do with it. There are lots of math routines in Maple, and we give you several different ways to use and interact with those math routines. We have a technology called context-sensitive menus. If you enter an expression into a Maple worksheet and you right-click on it, a context-sensitive menu pops up, giving you access to a number of different math routines. So let's apply a math function to this equation and plot the results. If I change the original expression and hit this button, you can see all of my plots and results update. The context-sensitive menus are truly context-sensitive. So, for example, if I type in a differential equation using dot notation to represent derivatives, and let's have a boundary condition on the first derivative and an initial condition. If I right click on this, you can see the context sensitive menus have changed. I can solve this equation analytically, drag the result to, say, a new math region, right click on the result, and plot it. So that was a moderately complex series of operations. I entered in a differential equation together with boundary and initial conditions. I right clicked on it to get an analytical result, and I plotted the result here. Bear in mind that I haven't used any commands. All I've done is entered equations, right clicked on them, picked math functions, and then got the result. No syntax or commands were needed. The context-sensitive menus go far and deep. So for example, what I can do is load a suite of commands called dynamic systems. If I now enter a transfer function in S, I now have a new dynamic systems menu here. I can now convert this transfer function to a different form, say a differential equation or a state space model, or I can generate various plots. So for example, here's a phase and magnitude plot. Again, all by the context-sensitive menus. There's far more I can do with the context-sensitive menus, but let's put them to the side for one moment. I also have commands that I can type in and use, and a full programming language. This, for example, is a command I use on a regular basis. fsolve solves an equation numerically. So if x plus log x is equal to 4, then x is about 2.9. Here's a command that solves equations symbolically. So this is a quadratic equation, and I can ask Maple to give me the two roots. By the way, I've been using keyboard shortcuts to enter in equations in proper mathematical notation. I can also use the expressions palette as well. So here, if I click on this, I get this mathematical template, and now I can simply tab between the different placeholders and fill them in. There are well over 5,000 commands in Maple with many command line options. Maple covers virtually every area of math, from probability and statistics to differential equations to linear algebra and more. If you right click on any command, you can jump straight to its help menu here. All of the help menus have a fairly standard look and feel, so if you know how to use and navigate one help menu, then you can do that with all of them. At the top there's usually an explanation of the syntax, but if I scroll down there are worked examples that I can copy and paste into my own worksheet. There are also links to related help pages here on the right hand side, and these links are a great way to learn about the wider ecosystem of Maple. You can create many different types of visualizations with Maple. I've already created a couple of simple plots using the context menus. I can also create plots programmatically using the plot command as well. So this is a sine curve between 0 and 1. If I right click on the plot, I can change the look and feel of the plot. For example, I can change the style of the line, the color of the line. I can add in labels to the x and y axes and a title, or I can use command line options. So if I add in the gridlines command line option, Maple inserts grid lines into the plot. I can also have a title. I can add in labels to the X and Y axes. I can change the viewing window of the plot and much more. We also have many different types of built-in plots. For example, in the thermophysical data package, you can create temperature entry charts of many different pure fluids. There are over 100 different fluids in the thermophysical data package, and you can get a customizable temperature and entropy plot for each one. These are just normal Maple plot objects, so you can add in lines and other visual elements to indicate the flow of a thermodynamic cycle onto the plots. Maple also has a fully featured programming language as well. And let me just prototype a quick program. In this program, we'll calculate the factorial of a number. So this is the factorial of 5. This is the factorial of 6. Once you've developed your program using Maple's interactive development environment and confirmed its correctness using Maple, you can convert it to many different language descriptions using tools from the code generation package. By the way, Maple also has command completion, so if I type in the first few letters of a command and I hit escape, the command completion menu pops up on screen and I can pick the command that I want. So Maple will convert expressions and procedures to C, C#, Fortran, Java, Visual Basic, and many other languages. So let's convert my simple program to C syntax. And there we go. Many of our users use code generation in Maple to generate C syntax and very large symbolic expressions. Converting the large symbolic expression to C by hand would be time consuming and onerous, but Maple does this instantly. So far, I've shown you how to do some math in Maple. You can also annotate your worksheet with text, graphics, images, and a variety of other elements. So let's add a title to this new worksheet. I can apply a predefined text format to this text with this drop-down menu. I can then drop down to a new math region by hitting Ctrl-J or Ctrl-K on my keyboard. I can do some math. I can insert some more text. And so on. I can also use sections to structure my worksheet. If I go to the Insert menu and select Section, Maple inserts this structure on screen. First, I'm prompted to enter a title for my subsection, and below that I have the body of the subsection, in which I can do math, insert text, and much more. You can also have sections inside sections, so let's insert a subsection. Have some more math, and so on. Each of these sections and subsections can be expanded and contracted individually. I can also insert images and picture files into my Maple worksheet by the Insert Image menu, and more. I can use all of these tools to create interactive, mathematically live design documents. For example, here is a Maple worksheet in which I have a diagram, some description of the problem. I then do some analysis. So for example, I enter in equations, I manipulate them, and throughout the worksheet I've used text, images, sections, plots, and much more to create a design document, an analytical application that can be shared, reused, and deployed easily. Moving on, I can also analyze data in Maple. I can import data from Excel spreadsheets, CSV files, binary formats, or from internet data sources. For this application, I'm simply going to prototype a very quick data file in an Excel spreadsheet. And save this onto my Windows desktop. If I go to the Tools menu and select Assistance, Import Data, I can point to the data file that I've just saved and load it straight into Maple. Let's give it a variable name, and as soon as I click Done, Maple brings that data in. I can now analyze and manipulate this data. I could, if I wanted to, right-click on this data and use the context-sensitive menus to manipulate this data. Or I could use commands. So let's plot this data. So here I have the first column on the x-axis plotted against the second column on the y-axis. Maple's joined the adjacent data points with straight lines, but if I wanted to, I could ask Maple just to show me the points instead. Let's try to do some basic analysis on this data. Let's try to fit a curve to this data. There's tools in the curve fitting package for fitting curves to data. And just to keep this simple, what I'm going to do is fit a spline to this data set. So here, Maple's fitted my spline, a smooth line that connects each data point. Of course, what I really want to do is plot the original data, the data points, against the smooth line on the same plot. I can do that easily within Maple using Maple's programmatic plotting tools. So first of all, I'm going to assign the result of this plot command to a Maple variable p1. I'm then going to create a second plot of my spline, and let's assign that to maple variable p2. Now I can stack one plot on top of the other. So here I have my original data and my smooth line. You can create many different types of visualizations with Maple. That's one of Maple's strong points. Let me show you a couple of examples. In this application, I'm downloading live earthquake data and plotting the location of the earthquake on a map of the world. Let's update this data. If I let my mouse hover over any of these points, a tooltip pops up giving me the location of the earthquake together with its magnitude. I can also quickly switch between different map projections as well and add different styling effects. So it's possible to create intriguing, compelling visualizations within Maple using all of the programmatic plotting tools. There are many other features in Maple, many other tools that I haven't had time to cover today. If you're an engineer, what I would suggest is that you browse the Maple portal for engineers. The link to the portal is on the start page, and it's this button here. This is a curated collection of tips, techniques, and applications that offer real tangible value for engineers. So for example, let's say that I wanted to learn about Maple's tools for generating fluid properties. I'd click on this. In the main body of the worksheet, I have a short description of the functionality together with links to real applications on the right hand side here. While you're using Maple, if you have any questions, then please do contact our support team at support@maplesoft.com and we'll be more than happy to help you. Thank you for listening.